Today we're going to build the Pop the Lock game using SpriteKit and Swift. And as you see here, you have a player going around the lock and you have to try to click on these yellow nodes before your player leaves the node. So if you get it in time, you unlock to the next level, and the next level has one extra node, and you progress all the way to 20 nodes. Now as you progress through the game, you get different checkpoints which will make the game a little bit harder. So now we're on level 5 and your player moves a little bit faster. First thing we'll do, of course, is open a new Xcode project. So we're going to select iOS and go to Game, Next, Pop the Lock is the name of the game. We can leave everything else the same. We want it to be Swift and SpriteKit. Next, and we'll hit Create. And let's grab some more space by double-clicking in there. So let's lock this into portrait mode. We don't want it to go landscape left or landscape right. We just want it to be a vertical screen. And now we'll go to the assets folder and drop in the assets that we'll need. And you'll find these on my GitHub, which will be, the link will be in the description below. So we have a player, which is the little red tic-tac. You've got the top of the lock, and then you have the orange ball. And then we're also going to add 2 sound effects to our project that we're going to use, which is the popping noise when you collect one of the balls, and then the unlock noise when you get to the next level. And let's drop these in under our storyboard. We will copy items if needed, and then make sure Add to Targets is checked as well. Now we have our sprites and the proper sound effects that we're going to use. So let's go to our Actions file. We don't need this, so we're just going to delete the whole file. Move to trash. And let's come to our game scene as well. We do not need this Hello World label, so let's delete that. And then come to our gamescene.swift file, and we're going to delete quite a bit here. So let's get rid of the 2 labels at the top. Get rid of everything inside did move. Get rid of everything inside touch down, touch moved, touch up. Let's get rid of this if let label inside of touches begin. All the errors have gone away, and now we have a fresh SpriteKit scene to start with. And one other thing I like to do in my new projects just to get started is come to our GameViewController.swift, and down here under View Ignores Sibling Order, we can type view.showPhysics and set this to true. And this way, when we have physics bodies in our scene, they'll be surrounded by a blue highlighted ring or square, whatever the physics body is, but you'll just be able to see where your physics bodies are, and it can help with debugging a bit. Okay, so let's close our game view controller and our game scene.sks. Close this window to the right and make everything a little bit bigger. Now going back to our game example, you'll see we have a couple different components here. We've got the lock itself, which has the lock circle and this little top piece. We have the inner circle and the label. We have the player itself moving around, and then we have the ball that you're going to collect. So 4 different pieces. So we're going to make 4 different Swift files and put the contents and separate custom classes within each of those, just to divide it up a little bit. So let's create the lock piece first. So let's press Command N to create a new file, Swift file. And we'll call this lock.swift. Make sure that your target is selected here. Okay, and we want to change foundation to SpriteKit because we need SpriteKit, not foundation. And like I said before, we have 2 parts here, the top and the base. So we'll create 2 classes in here, one for the top and one for the base, which will both basically be SK nodes or SK Sprite nodes. So let's make class lockTop, which will be SK Sprite node. Now we want to create a initializer. So init, and we're going to get an error here saying we need the required init. So fix, it'll do that for us. And what we want to do is create our texture here. And we'll get another error saying that super.init wasn't called yet. So we will do that now. Super.init. And we need a texture here. So we want to do texture, color, and size. But before we plug in a texture here, let's create a variable with our texture. So let texture equals skTexture. And we'll do image named lock_top. For the texture, we can just use texture. Color, we'll use .white. The color doesn't matter because it's going to pull from the texture anyway. And then for our CG size, we want a texture .size, and that should do it. We don't need to add a name, but I like to do it anyway just in case we might need it. So name lock top, and then the position, we're going to put it at CG point. Want to meet X of 0 and Y of 100. And because I made the sprite on a little bit of a small side, I am going to increase the scale by calling set scale, and we'll set it to 1.5. And we'll set our Z position to be -1 because we want the lock top to be behind the base. And last thing we'll do is add our anchor point, CG point, 0.5, 0.5. And this just sets the anchor point of the sprite to be the middle of the sprite. So that's it for the top. Now we want to work on the base. So class lock base, and this is going to be an SK node, not a sprite node. And the reason why, if I pull up our example here, it's just a circle. So we can easily create this node using a SK shape node rather than a sprite node. So let's do that now. We're going to say let base equals SK shape node. And we again need our override init here. And we're going to get a complaint that we don't have a required init, so let's add that as well. Super.init. And we'll get a complaint that base wasn't initialized before super.init. So let's do that now. Base is equal to SK shape node. And this is going to be a circle of radius 200. We'll set our base.stroke color to be .gray, and base.fill color is going to be equal to, we want to create a color here using SK color, and got to scroll down a little bit to our red, green, blue, alpha. Now we want to make this basically the background color that we already have. So I'm setting this color inside of here to match the background color of the game. And an easy way to tell this would be to open up our color meter. And you'll see that the background of the game is 38, 38, 38 on the RGB scale. And same thing here because I've set it in the game. So let's call 38.0 out of 255.0 and just copy this and paste it for the rest. Alpha, we want to be 1.0. Then for our base.line width, we'll set this to be 30. And then underneath our super.init, we can set the position of our base equal to CG point. X will be 0 and Y will be -100. And just to be sure, we'll set our Z position to be 0, and then we want to add child base. So we're taking our SpriteKit shape node and adding it as a child to our overall SK node. So with the lock base and the lock top done, let's go back to our game scene and add them in. At the top, we will Right, let lock top equals lock top, and let lock base equals lock base. Inside of our didMove function, this is where we can add the lock top and lock base as children to the scene, which will make them appear. So we'll call add child lock top, add child lock base. And now let's run this, and hopefully we should have the base and the top there. And there they are. So I forgot to change our deployment target. This is set to a 7th gen iPod, so let's just change that now to be our iPhone 13 Pro Max. So with the lock complete, now let's work on the label on the inside. So again, it looks like a circle shape node here, and then in the inside would just be a text label. So let's do that. Command N, create a new file, and call this label.swift. Make sure your target's set. And let's change foundation to SpriteKit again. And again, what we'll do is put our label background and our label inside of this one sheet here, just to make it easier. So let's create the label class itself first. And this will be an SKLabel node. And once again, we're going to call our override init and get our super.init called here, and then get our error and let it fill it in for us. Fix. So we want to set our text to be string of 1, because 1 is the first level that we're starting with, and then we can increment this later with a function. Let's set our font size to be 128. Font name will be Futura bold, and then font color white. And then let's set our position here. So for our X, I'm going to put -8, and our Y will be -50. These are just the values that I found worked well with this particular font size and the size of the sprites that I was working with. You can mess around with this and put it wherever you want, but this worked for me. And then let's make our Z position, set it to 4. Doesn't really matter, this could be 400. I just want to make sure that it's in front of everything else. Okay, and then let's create one function in here called updateLabel. And we'll pass in a single parameter called level, which will be an integer. And all we're going to do is update our text to be a string version of that level. So now in our main game scene, whenever the level increments, we can just pass that incremented level in through here, which will update the string text label of our label. So that's it for our label class. And let's minimize this for now. And we're going to create another class here called class label background. And this will be an SK node. Again, override init. Let's call our super.init. Wait for the complaint from Xcode and have it fix it for us. Now, looking at our example, I ended up creating 2 separate SK shape nodes in here. One for the blue background and then one for the ring. It kind of gives it this double ringed look effect. I played around with this a little bit, and you can do whatever you want, but this is just what I thought looked nice here. So let's make a ring, and this will be an SK shape node, and then a background shape node. So ring will be an SK shape node, and we'll call circle of radius 100. Let's copy that and paste it for background. And I'll set the ring.stroke color to be light gray. We'll set the ring.alpha to be 0.5. Ring.line width will be 30. and ring.zPosition 0. For our background, we'll say bg.fillColor will be blue at first. This blue will be for the first couple of levels. bg.alpha will be 0.8. bg.linewidth will be 0. And bg.zPosition will be 1. And then again, because this label background is an SK node, we need to add these two ring and background SK shape nodes as children to this overall container node. So underneath our super.init, we'll call add child on ring and add child on bg. And we do want to make one function here, just like we had the update label. We want to update the background color of our background based on what level we're on. So let's create that function, update label background. Again, we will take in a level as an integer and then work with that. So what we'll do here is a switch case. So if we're between certain levels, we will switch the background color accordingly. Switch level, and we have case, so for 1 through 4. So for 1 through 4, we will set our background color to be blue. And for our default, we'll leave it as blue. Now we're done with our background and our label, so let's add them to our scene. Let's go back to gamescene.swift and add under here, let label equals label, let label background equals label background. So what we're going to do is add our label and label background and player and collectible as children for the lock base. So let me open up Simulator and explain why. So when we complete the level, we want this whole thing to move over to the left and come in from the right side. So just like that. In order to do that, there's two ways. You could do what we're going to do, which is adding them as children, and then you only have to move the lock base over and all these pieces will follow because they're all children. Or you could move them all individually. I find the first way to be easier, so let's just do the first way. So let's say lock base dot add child label and lock base dot add child label background. And actually, before we run this, I am going to set this to be iPhone 13 Pro just so we don't lose our other simulator in the background. Let's run it on the 13 Pro and see what we get. Okay, we have our background and our label. Now let's work on the player node. So let's create a new file, Command N, Swift file, and we'll call it player. Again, set the target. Change this to SpriteKit. And we will create a class player, and this will be SK node. Override init, super.init, wait for the error, and fill that in. Our player will have three properties, so let the first one be ticker, and this is going to be an SK sprite node. And we'll have a variable for ready, which will be a Boolean. And what this is that every time we pass through and begin a contact with this yellow ball, we'll be ready. So if the player clicks during that time while they're ready, they collect the node. As soon as they leave that contact there, they will no longer be ready. So we'll set it back to false. And then we want a var velocity, which is going to be a CG float of -1. And -1 in this case will be clockwise, and 1 will be counterclockwise. And we're getting an error because we have not initialized our ticker. So let's do that. We'll set our texture be SK texture, image named, and this will be the lock player. And then we'll say ticker equals SK sprite node using texture color size, white, texture.size. So let's set our ticker position first. And this is going to be CG point X of 0 and Y of 150 because we want it to be above the label. Then ticker.anchor point, again we'll set that to be CG point of 0.5. We're going to set our scale. Again, just like the lock piece, I actually made this sprite a little bit too large, so I am scaling this one down in this case. So 0.8. And then ticker.z position, we want it to be in front of everything else, so we'll set it to be 2. And now we want to create a physics body for our ticker. And the physics body will allow us to check whether or not we are touching or making contact with the collectible node that we'll make in the future. So let's do ticker.physicsBody equals sk physics body. And for our texture, let's come down here. We want texture and size. So texture will just be texture, and size will be texture.size. So this will create a physics body around our ticker that will collide or interact with other physics bodies. And now we can set a few properties of the physics body. So let's say ticker.physicsBody is dynamic. We want this to be true because we do want it to interact with other nodes, namely the collectible node. And actually, let me increase the size here a little bit. And we want to set ticker.physicsBody affected by gravity is false, since we don't want it to fall off the screen when we start. And ticker.physicsBody allows rotation, just set this to be false. We don't really need to set it, but I just like to set it anyway. Now before we work with the collisions, we would like to create a enum that has our collision types in it. And I'll explain what that means in just a second. So let's come back above our player and create an enum. And we'll call it collision type UI int 32. And we have two different cases here. One for the player, set that to be 1, and one for the collectible, which will be 2. So for collisions, SpriteKit uses bit masks. So you have 3 different bit masks, which are the category bit mask, collision bit mask, and contact test bit mask. And here we're just basically setting the player to be 1 and the collectible to be 2, so that we can check the difference between the two of them. And SpriteKit will do the bitwise comparisons using these two numbers. So let's come down to our physics body and we'll set the 3 different masks here. Ticker.physicsBody.category bitmask is equal to collision type.player.raw value. Now if you hold Option and click on this, you'll get an explanation. And every physics body in a scene can be assigned up to 32 different categories, each corresponding to a different bit in the mask. So basically we define which bits and which masks we want to use inside of our game, and then provide them to these 3 different properties of the physics body, and SpriteKit will do the work for us. So the other one we want is ticker.physicsBody.collision bitmask. And there's no collisions in this game because we're not bouncing anything off of each other. We're just doing contact testing to see when 2 objects are touching. So for this case, we'll set it to be 0. And then ticker.physicsBody.contact test bitmask. This one, a mask that defines which categories of physics bodies cause intersection notifications So whenever they intersect and touch each other, that's the one we want to work with. So we want a physics contact test notification to happen whenever our player touches our collectible. So let's just copy this and change player to collectible. Now in our collectible file, we would do the reverse. So the collectible will be the category, and it's going to have a contact with the player. So with all of these physics bodies properties set, we can now do add child ticker. And now we're done with our player class. So let's close player, label, and lock, as well as assets. And then we'll add our player. Again, we're going to add it to our lock base. Add child, player. Let's run it and see what happens. And there's our player. And it's kind of hard to see, but there is a light blue outline around here, and that is the physics body that we set. We set it to show to be true, so that's why you can see it as a light blue outline. And the last piece we want to add is the collectible. So Command N, new file, collectible, set the target, create. We're going to import SpriteKit again and create our class collectible SK Sprite node. Same thing as always here. Now I'm going to add two properties here for the radius. And basically, again, the problem is that I created the sprites after working on the project initially. So the sprites are a little bit, basically the wrong size. So I scaled them down a bit. So what I'll do is add two properties here, sprite radius, CG float, and adjusted radius, CG float. It'd obviously be a better idea to create the sprites afterwards, so you don't have to do this in hard code values. But again, this is just what I did, and this is a mistake I would learn from. So what we'll do underneath our let texture here, we'll say sprite radius equals texture dot size dot width divided by 2, and then the adjusted radius is going to be 200 minus 19 minus sprite radius. So this will just make the radius of the sprite and the physics body work properly within the numbers that I previously calculated for the other sprites. And underneath our super.init, we'll call z position to be 1. We want it to be in front of the lock base. And then we're going to do our physics bodies. So self.physicsBody equals sk physics body. And we'll do texture and size will be texture, size will be texture.size. Physics body dot is dynamic. Want that to be false. Physics body dot allows rotation, false. Physics body dot affected by gravity, false. And then we need to set the 3 masks again. So let's come back to our player, and we can hold Option and highlight these 3 like that. Copy. Set those here, and again we want to inverse them. So collectible should be player, and player should be collectible. So now our category for this physics body is the collectible, and it contacts with the player. So let's go to our game scene and add our collectible. Var collectible lock base dot add child collectible. Now let's see what happens if we run this. So our collectible is in the center, and that makes sense because we added it as a child to the whole base, so it's going to be in the center of the base. But we need to set some functions here that will set the position correctly. And basically we only want the position to fall in this ring that's out here. And this goes back to the adjusted radius that I mentioned before. With that adjusted radius, we can get the proper position within this ring for our collectible to be only falling in this ring. So let's make some functions now that will do that. Come back to collectible, let's scroll down a bit here, and let's create a function that will set a random position. So before we fill in anything here, we want to create two properties in our collectible up here, which will correspond with the angle. So we'll have a current angle and then the last angle used. Let's go back down to our set random position here and set our last angle equal to our current angle. Okay, and now we want to set our current angle to be a new random angle. So let's call cgfloat.random in, and the range is going to be 0 to 360. And we want to change this to radians. So let adjusted angle equals current angle times pi divided by 180. Sine and cosine require radians, not degrees. Now that we have our two new x and y positions, we can set the position of the sprite to be cg point x and y. Looks like we're getting an error here. Current and scope. This should be current angle. There we go. So then at the end of our initializer here, we will call set random position. And now let's run. So we got down here. Let's run it again. Down there. And we're going to need two other functions in this class that will also set the position. So let's make those now. Minimize this one, and we'll set a function for opposite position and a function for close position. And this is going to take in player velocity. Now the opposite position will do exactly what it says. So it's just going to set the angle to be 180 degrees from where we are now. And paste. Now we're done with this one. Done with this one. And for our close position, this is basically going to be, open this up here in Simulator. So when we click, we want to create another node that's close by to where the player is based on the new direction that they're going. So it's going to create one over here or over here, somewhere close by. And it can shrink, it can go to a different range of angles, let's say. So let's set our last angle first to be current angle, and that our random next angle will be a CG float random in. And looking at this again, actually let's just look at this one. So if this is where we last left off, we want somewhere between this 180 degree line. So we want the new position to be somewhere in this 180 degrees. So that would be the top end of our range. But if you did like a 10 degree angle, it's going to move the orb maybe like right here. And that's not very fair. You're not going to have the reaction speed to be able to click that instantly. So to be a little bit more fair, you could do a 90 degree angle from 90 to 180. But let's make it 60. So that would be about here. So 60 to 180. So the new collectible will spawn somewhere within this 60 to 180 range. That seems fair. So 60, 180. Then we want to check our player velocity because that will change where the next angle is going to be if we're adding or subtracting it to our current angle. So if our player velocity is equal to -1, meaning we're headed clockwise, Then we want our current angle to be equal to our last angle minus our random next angle. Otherwise, we're headed counterclockwise. So let's set our current angle plus last angle plus random next angle. And then everything else is the same. We're going to set the adjusted angle, the X, Y, and then the position. So copy, paste everything, and we're done. Let's minimize this one. And now our collectible class is complete. So with our collectible done, we can close this file, and we're done with all of these other files and creating files, and now we can go to our game scene and just work exclusively there for now. So in order to work with physics in our game scene, we're going to need to extend the SK physics contact delegate protocol onto our game scene. So let's come down to the bottom and do an extension of game scene SK physics contact delegate. Now this protocol has a did begin and a did end method, and each of them basically happen whenever there's a physics contact. So one when the physics contact begins and the other when it ends. So let's type did begin to add our begin function, and then did end for our ending one. So just to show how this works, we could do print started contact and then ended contact. And in order for our game scene to detect these changes in the physics, we are going to have to come up here and set the physics world dot contact delegate. So when two physics bodies come in contact with each other, this will be called, and we'll set that equal to self. Now, if we run our code, well, we are not actually getting any contact because our player object is not moving. So let's make the player move. In our update function, we'll call player dot zrotation plus equals 0.03 times our player dot velocity. So now let's run and see the contacts and the player moving. So they're moving, and we see we have started contact and ended contact. Although you'll notice that it's duplicated. So we're getting two starts and two ends. We can work around this basically by checking the time between the two starts and separately the time between the two ends. And if they're too quick, then we will only register one of them. So let's do that. So back at the top here, we'll create so when the touches start, we'll set our start time, and then when the touches end, we'll set our end time and use our contact time and our contact to determine if it's in the window that we are looking for. So let's set our starting time here, date.now, and then when the end happens, we'll set our last contact time for the end to be date.now.time interval since our last end contact. And then we're also going to put last end contact equals date.now. So below our last end contact time, we want to check if our last end contact time is less than 1, then we're going to return. So essentially what we're saying is, let's check to see if the time between these two ended contact messages is less than 1 second. And if it is, then return. So we're assuming that these two ended contacts are going to be less than 1 second long, and we're going to return. This way we don't get duplicates. So let's move this print statement below and see if it actually worked. Let's run. So now we only get one ended contact, which is what we want. So let's delete some spaces here. Now that we know if we make it past this line, we have one end contact time. So what we'll do is set our player.ready equal false. So the contact has ended, the window of opportunity for the player to click is now gone, so we should set player.ready to be false. We're also going to set our ending time to be date.now. What I want to do is, instead of calling end contact here, we're going to call a function called restart level. Since we don't have it, let's extend our game scene right now and add function restart level. If the contact began and then ended and the player did nothing about it, then they have to restart the level. And now let's work with the player tapping the screen and what happens during that time. So let's come up here, and on the second thought, we don't need any of these except for touches began. So let's delete all of this and delete touch moved and touch up. So we only work with touch down and touches began, so when the user taps on the screen, this function here will be called. So when the player clicks the screen, we have to see if the player's red ticker is inside of the orb. If it's not, then they will basically lose that level. If it is, then they win that current. So what we want to do in here is, when the player taps the screen, we want to see, is the player in a ready state? Meaning, is the ticker inside of one of the collectibles? If it is, then they're ready to collect that collectible. If they're not, then they have to restart that level. So we can say if player.ready, and here we would collect. Otherwise, let's restart our level. And since restart level doesn't do anything right now, let's just say collectible.setRandomPosition, just to show that it's working. The orb should move, but it's not. Now if I tap, the orb does move to a new random position. But it should be occurring when this happens as well. So to get around this, let's hit stop here. And we'll come back into our collectible, open up our random position here, and instead of just setting the position like this, we'll do a SK action. So we'll call run, and then we'll do dot move and to by duration. So we're going to move to CG point, which will be X and Y will be Y, and the duration will be 0. And now we can delete this position here. Let's copy this and expand our other two and make sure we change it in there as well. Let's close that back. And now if we run again, we should get a new random position when the contact ends, which we do. And if I tap, we get it as well. So when we're restarting our level, sometimes we might want to set the close position like we did before, using that set close position method we created. So let's create a default value inside of our restart level function call that will default to basically being a random position. So we'll set close as a bool, which will equal false. And then inside here, we'll say if close, we'll do collectible.setClosePosition based on our player.velocity. Otherwise, we'll set a random position. Since we're restarting our level, we're also going to want to reset some values here. So basically, how many collectibles are left in this level, as well as the current level that we're on. So let's set those at the top of our file here. Since the level restarts, we basically want to set our remaining collectibles back to our current level. So if they were on 5 and they collected 3 of them, but then they messed up, we'll go back to level 5. And after we set our remaining collectibles, we want to update our label as well. So update the label back to our remaining collectibles. And we should also make sure that the player is not ready, just in case they were for some reason before. So our restart level function is working properly now. Let's go back to our tap. So when they tap, if they're ready, we want to actually collect the collectible. So let's make a function here called clear pin. And let's scroll back down to create the function inside of our extension here. Func clear pin. So let's go back to our other example here. So when the player collects the pin successfully, we see that we passed the level because there was only one pin we had to clear. Now there's 2 pins. So if we clear 1 pin, the label has to go down, and they failed, so it went back to 2. But if they clear both pins, the position gets successfully changed, and then if they clear all the pins in the level, it moves to the next level. So the location gets changed again. 2, 3, and then we go to the next level. So let's do player.ready equals false. We always want to make sure they're not ready after clearing a pin. And we also want to turn the player around. So we want to set the velocity times equal -1. So if they're clockwise, they'll go now to counterclockwise. We should also set our remaining collectibles minus equal to 1 and update our label as well. And if our remaining collectibles is equal to 0, that means we passed the level. So let's call next level, and we'll have to make a function for that. Otherwise, we want to restart our level with a close position. And just to get rid of this error, let's create next level. So if there's no remaining collectibles in the level, we go to the next level. Otherwise, we're clearing the pin. So we're going to set a new pin position that's close by. We said right here, if close is true, we'll set a new pin that's close by to where they currently are. Now before we continue, let's come back up to did begin in our physics contact, and instead of printing this statement, we want to set player.ready is equal to true. Let's run it. Okay, so it's resetting properly. And now if we click, you saw it went down to 0. Click, 0. And if we want to add a sound and an animation when we collect our pin, we can do that inside of our clear pin function here. So let's do collectible.run. So run can take a sequence. So if you do dot sequence, this is a sequence of actions that run sequentially. So it's an array of actions. So let's create an array. And the first one we want to run is scale to size. So we want to scale our collectible to be 0. And the time interval should be 0.1. So we're going to make it disappear basically. And we want to play sound file named pop.m4a. So that's this file we created over here. And then bool, we do not want to wait for completion, so hit false. And then our last action will be our fading alpha to 0, duration 0.1. So it'll shrink, disappear, and play a popping sound all at once when we collect it. And then we should probably come down to our restart level here and fade the collectible back in properly after it's set. So let's run this and see what happens. So if we click, we get the disappearing as well as the sound effect. And now we want to implement the next level portion. So if they beat the current level they're on, we are going to advance by 1 level and set our remaining collectibles equal to our current level. And we want to update our label to our remaining collectibles and update the label background to our current level. So that'll change the color of the background based on what level we're on. Again, we should set our player ready to be false just in case, and then call restart level. So let's try this. Level 1. Now we're on level 2. You'll see we're not getting subtractions correctly. Now the reason that we're having the problem with the numbers not declining is because we're calling restart level inside of our clear pin, and this is resetting our remaining collectibles back to 2 every single time. So we can add another parameter in here called advance bool equals false, and we want to say if advance if not advance, and we will say up here advance true. Now when we run this, now we can advance to our next level. You see our background changed automatically. But inside of our next level method, we want to make things a little bit more spicy, right? We want to add some more animation so we can move the lock pieces around and play a sound as well. So let's work on that now. First of all, let's set another flag here. If our current level is greater than or equal to 20, then we will end the game. We'll have to put another one down here called end game and work on that later. Otherwise, we are going to call our movement pieces here. So let's create another function and we'll basically call this move lock. Func move lock. And now we'll put all of our animations in here just to keep it clean. So let's open this up just to get an idea of what we want to do. So we want the top lock piece to basically ease down and then go back up so it looks like it's unlocking. And then we want to move the whole thing left out of the screen, eased out. And then once it's out of the screen, we'll move it back in from the right. And we'll also, of course, play the sound as well. So let's start with the lock top piece. So let lock move down equals, and we're going to create a new sk action dot move to, we want to move it down. So we're going to set our y position to be 20 and our time interval will be 0.2. And we want to set the timing mode of our action so we can control the speed and curve in animation using the timing mode. Equal to be ease in out. And now let's do the same thing with lock move up. And then we want the whole lock top to do this animation. So lock top dot run. Again, we're going to call a sequence here, array, and we want to first wait for a little bit. So let's wait for a second. Then we want to play a sound. So we're going to play the unlock.mp3 that we have here on the side. Wait for completion, false. And then we want to lock move down and lock move up. So let's run this and see where we are. missed that somehow. Okay, so our unlock worked and the sound played, but this should have gone back down to its position to lock itself. Otherwise it stays like this. So we will deal with that off screen once we move the lock away. So now let's focus on moving the lock to the left. And then we also want to copy and paste this for the lock top and lock base move in as well. So these actions will now make sure that the lock goes to the left and then comes in from the right side of the screen. So now we want to run those. So we'll do lock base dot run. Again, we're going to do a sequence here. Now we can do the same thing for our lock top. And that should be it. So let's see where we are. So our animation for unlocking is going a little bit too slow. We don't see it. Everything leaves the screen too fast. So let's change the duration up here for our lock top unlocking to be 0.5. Let's try this again. Not bad. And we could actually add some time here. Make this 1.4, 1.4. There we go. So next, first of all, let's minimize some of these. We have endgame to still do. And back up here, in our update section, we should change the player's rotation based on the current level that they're in. So let's do switch current level, case 1 through 4. This is exactly the same cases as we had in our other file for our collectible. So I believe that was in set close position. No. That was not in the collectible file, that was in the label. So let's go to our label background and just copy all of this. Minimize it again, close our label, and then back in our update function, instead of BG, we are going to copy this. So now the difficulty progresses, and let's get rid of this one here. Now let's test this just to be sure. So as you can see, our animations go a little bit fast and the player still moves while the levels are switching, but that's not, a huge concern for right now. That's something you could fix if you wanted to. But you can see that we are going faster now. So let's see if we can get to 10 just to try it out. just to make sure that it's working. There we go. So last thing to do would be to implement the end game functionality. Let's minimize that one there. Let's minimize clear pin. Not sure why these all expanded, but that's okay. So let's play a cheesy little sequence of sounds. I'm not going to type it all out. I'll just copy paste it for now. But basically we're going to play the unlock sound 3 times. And then we're going to fade everything out. And then we should create a label and a particle so that we can just display like a little splash screen with fireworks. So let's first create the label. So up at the top, let's put one more node up here. SK label node, text, victory achieved. And let's go back down here. Say victory dot font size equals 50. Victory dot font name is equal to Futura bold, and then add child victory. Okay, so let's add our fireworks now. So Command N for new file. Swift file, no, we want a particle file. Fire, sure. And make sure the target is set. We'll call this fireworks. Create. And we're getting some glitch out here, so let's just open this side editor here. We'll set the position range to be 90. And everything else looks okay to me. So let's just leave it as it is. Super glitched out, but we'll worry about that later. Let's close this for now. Actually drag it up in here. And then we'll add our particle here. So let particle equal sk emitter node based on our file name of fireworks. Adding an exclamation because we know it's going to be there. Particle dot position dot y, we'll set it to be -650, so it's down below. And then particle dot alpha, we don't want it so bright, so we'll set that to be 0.2. And then our particle dot set scale, make it a little bit larger, not 0.8, let's make it 8. And then add child particle. So we tested if our end game is equal to 20. That's too high, so let's just set this to 3 because I don't want to go through 20 levels, just to make sure this is working. And let's see here. Super janky. I'm not sure why that lock top didn't disappear right away. We can worry about that later, but we did achieve our victory. We have our bonfire here, and we just captured a lot of souls. So to fix that locking issue, let's come in here and put an else block, because I forgot to do that before. So if we end the game, we're not going to continue on with this other code. And then let's also set the duration of our fade outs here to be 0. Let's run this one more time. And 1, 2, 3. So we got our victory achieved, we got our bonfire, collected all of our souls, and on to the next game. That's it for today's video. I hope you enjoyed it, and learn something new. This is pretty fun to create. I'm going to try to create other things like this, and if you have any other suggestions for games you might want to see, leave a comment in the description. Thanks for watching, and have a great rest of the day.